Okay, class, I was assigned to give a review for the course Calculus 3 Math 148. Okay. Okay, let's start with this problem class. Actually, this is an application involving improper integrals with infinite discontinuities. Okay. Okay. So class, so this is the problem now. Find the area bounded by the curve y equals 1 over square root of 4 minus x squared. Its asymptotes and the x-axis. Okay, so of course we need to draw the figure first. So obviously class, we have to determine here asymptotes first. No? For the vertical asymptote class, diba, we simply equate the denominator to 0. The denominator is square root of 4 minus x squared equals 0. Then remove the radical, so we square both sides, follow. So that would now be 4 minus x squared equals 0, where this is factorable class. Okay, it's now 2 minus x, 2 plus x equals 0. So x values here plus 2 and negative 2. Okay, do we have horizontal asymptote class? What do you think? Anyone in the room class, do we have horizontal asymptote? None class. Okay, so this is now the graph class. Okay, so we have here class x equals negative 2 as a vertical asymptote, and we have here x equals 2, another vertical asymptote.
Eh, loba. Ay, masaan?
That's for y. Okay. So this is now x is equal to 2. Okay, next is, let's have some points class on the curve. Assigning x and y. Okay. Assigning for x plus, let's say, negative 2 plus. So obviously we have an undefined value for y. If that is 0 plus, that would be 1/2. And if that is 2, we also have an undefined value for y. Okay, so we now at that point, this is 0, 1/2 plus. So the curve class is asymptotic to the line x equals negative 2, and then it will pass through the y-axis at that point 0, 1/2, and then it is asymptotic to the line naman x equals 2. Okay, that will be the graph of the equation y equals 1 over 4 minus x squared. So plus, we want the area bounded by the curve, the asymptotes, and the x-axis. Of course, we will consider this as the region in which we are to compute for the area. Okay, so class, since it is symmetric with respect to the y-axis, okay, so we may have the limits instead here from 0 to 2. Okay, then we just multiply it by 2. So this is the strip that we will consider the vertical strip class, okay, such that if we try to exaggerate this instead of a rectangle, that the area of the rectangle is length times the width. Since this is just a representative strip class, a very thin strip, so that would now be for the height y and for the base as units. Okay, so we have the differential area of the class as y dx, and then integrating it, we have now the area as the integral of y dx. Okay, so for the limits, we have here now 0 to 2, then just multiply this by 2, because since it is symmetric with respect to the y-axis surface. Okay, so with that, we now replace y here by 1 over the square root of 4 minus x squared dx with limits from 0 to 2. So class, you can notice now, if we replace x by 2 here, the function is undefined. So that's why this is an improper integral with infinite discontinuities. We interpret the infinite discontinuities as vertical asymptote. Okay, we have the presence of vertical asymptote. So what's next now, class? We apply the formula for improper integrals with infinite discontinuities. This is of case 1 class, in which the upper limit, the reason why the function is undefined. So we have here the limit of the integral of dx all over the square root of 4 minus x squared, with limits from 0 to b as b approaches to, okay, what is this class? Is it from the left or from the right? We have here 0 to 2, right? So it is left of 2 plus. So that's why we have by the negative. And do not forget there are 2 plus. A constant, we just move out that constant. Okay? So what's next now? This is an integral will be inverse sign, right? So we have now 2 limit of inverse sign of x over 2. You still recall the formula, class? The integral of pu all over the square root of a squared minus u squared as inverse sign of u over a plus c. Hello? Then we have here the limits from 0 to b. Okay? 0 to b. Zero to b plus. Okay. As b approaches 2 from the left. Okay. Then we now substitute the limits for x plus 2 quantity limit of inverse sign b over 2 minus inverse sign of 0 over 2 as b approaches 2 from the left. Okay, so this is now 0 plus. Okay, and then we have 2 limit Plus there's no more limit since we will now substitute b here by negated limit. So it's now 2 times inverse sine of 2 over 2. Inverse sine 2 over 2 plus is pi over 2. Right plus? So this will give us the answer as pi. Okay, this is now the area bounded by the curve y equals 1 over square root of 4 minus x squared is asymptotes and the x-axis. Okay, take note that the inverse sine of 1 plus is pi over 2. Okay, we may now take a screenshot or a photo of the solution here plus. Okay, do you have any question, class? Anyone in the room? Question, class, before we consider the second problem. Can I move to the next slide now, class? If there's no question, later than taking a screenshot of the solution.
I now clear.
Okay, I now clear the drawing, class, or the solution. I'll go to the next slide now. Okay, na class, ha? Okay. So let's have a problem involving sequence classes, specifically the limit of a sequence. Okay. So find the limit of the sequence. It is expressed plus in the bracket notation. And straight e to the negative n equals 1 to positive infinity. So you're already familiar plus in the evaluation of limit of functions. Plus sequence is considered a function. Okay. So with that, we have here the limit of n squared e raised to negative n as n approaches positive infinity. So what do we have here plus? If we substitute n by infinity, that will give us infinity times 0, right? Plus, it's a linear terminal. Okay, so we need to derive the function into its equivalent form. That will now be the limit of n squared over e raised to n as n approaches positive infinity. Then if we replace n by the infinite limit, this time the form now plus is positive infinity over positive infinity, or simply infinity over infinity, an indeterminate form. Okay, so the first that comes into your mind now, if we have this infinity over infinity, we apply L'Hopital's rule. However, we cannot directly apply L'Hopital's rule, so what we do first class is to replace n by x. Okay, so with that, we now have the limit of x squared over e to the x as x approaches positive infinity. Again, we will now this as infinity of infinity. So using L'Hopital's rule, this is differentiating numerator denominator separately, where the derivative of x squared plus is 2x, derivative of e to the x as e to the x as x approaches positive infinity. When replacing x by infinite limit, still this is infinity over infinity. So we now apply L'Hopital's rule plus. So this L'Hopital's rule may be repeated plus 5. So with that, we have the limit now of derivative of x is 2, derivative of e to the x as e to the x as x approaches positive infinity. So what we have now plus is 2 over e raised to positive infinity, that is replacing x by negative limit, where e raised to positive infinity plus is positive infinity or simple infinity, where a number of the infinity is 0. So with that, our conclusion, the limit of x squared e raised to negative n as n approaches positive infinity is equal to 0. Any question, class? With any question, you may now take a screenshot of our solution. Class, I need to clear what is written here now, class, so that I can proceed to the next slide, class. Okay? I think we're done. Okay, so I'll go to the next slide now, class. Okay, let's have the third problem here, class. Still, this is under CO2. Ratio of successive terms, class. Okay? Are you still familiar with ratio of successive terms, class? Okay, that would be an plus 1 all over an. Okay? Compare it with the value of this ratio with 1 plus. Okay? If it is greater than 1, it's strictly increasing plus. If it is less than 1, strictly decreasing. Okay? So, for our an plus, it's 10 factorial. Okay? An rather is n raised to n over n factorial. What about an plus 1? So we just replace n here by n plus 1. So this is now n plus 1 raised with 2, n plus 1 all over n plus 1 factorial. Okay, n plus 1 factorial. So with that, we need to simplify plus for our n factorial. For our n factorial, yes, for our person. For our n factorial, we define this as n minus 1, n minus 2, n minus 3, and so on. So with that, we may now define n plus 1 factorial as using this as our basis class. So we replace now n by n plus 1. Then here it's n plus 1 minus 1. So with that, this is now n plus. Okay. Next here plus n plus 1 minus 2. It's n minus 1. If you notice, this is now similar to this. So with that, we will define quantity n plus 1 factorial plus as simply quantity n plus 1, okay, n factorial. So, getting now the ratio plus, this is n plus 1 raised to n plus 1 all over n plus 1 factorial. Okay, we proceed to multiplication. We invert this now, class. Follow, we invert this. That would now be n factorial all over n raised to n. So we now consider the simplified form plus for this factorial notation. So we have n plus 1 raised to n plus 1. And then for our n plus 1 factorial, we will now have as n plus 1 n factorial times n factorial all over n raised to n. So this cancels now, class. Okay. And then okay, so what do we have now, class? We may rewrite the numerator here as n plus 1 raised to n plus 1. And for our denominator, we have n plus 1 times n. So this cancels us. Then rewrite this now plus as raised to n to cancel. Then this is now n plus 1 over n raised to n, or this is also 1 plus 1 over n raised to n. So we now compare it with 1 plus. What do you think? Is it greater than 1 plus? Is it greater than 1? So it's very obvious, class. It will be greater than 1 for the value of this ratio. Okay? It is greater than 1 plus. So if it is greater than 1 plus, we can say then that the sequence, class, is strictly increasing. Okay? So the monotonicity of the sequence is determined here, class, using the ratio of successive terms. Okay, we may now take a screenshot, class, or a photo of the solution. Do you have any questions so far? Class, you may use your mic if you have question, class. Okay, you may interrupt me if you have questions, class. Okay? Yes, anak. Anong tanong? Someone often his audio. Yes. Ano yun, anak?
Wala daw po, sir.
Okay, wala. Okay, so I'll proceed now to the next slide, ha? Okay. So I'll clear the slide now, class. Then, so I'll go to the next slide. Okay, we have the convergence test now, class. Okay. So determine whether the series converges using the indicated test. Okay, so for letter A, class. For letter A, we are to apply divergence test. If you set a call class under divergence test, we are to evaluate the limit of UK as k approaches positive infinity class. Here, our UK is k squared plus k plus 3 all over 3k squared plus 1. So we now evaluate the limit of our UK k squared plus k plus 3 all over 3k squared plus 1 as k approaches positive infinity. Of course, we have different ways in evaluating the limit, I'll just give you a technique na lang class. Okay, we'll consider here the end behavior of the function, but this is only applicable if both members class of the rational function are polynomials. In this case, both class are polynomials, numerator, denominator. So we take now the leading term here, that of numerator, leading term is k squared, that of the denominator, the leading term plus is 3k squared as k approaches positive infinity. And we may simplify this now plus as the limit of 1/3 as k approaches positive infinity, where the answer plus is 1/3. Since this is not equal to 0, diba, the theorem states that if the limit of uk as k approaches positive infinity is not equal to 0, the series diverges. Okay? So that would be the conclusion test. So this series here diverges. Okay? Next class is, we have this series using now integral test. Summation of k, e raised to negative k, uk equals 1 to infinity. Okay? So on the integral test class, our f of k is k e raised to negative k. And then we now have our f of x here as x e raised to negative x. So this would involve class the evaluation of an improper integral. That means we have the integral now of x e raised to negative x dx with limits from 1 to positive infinity. Okay? So we now use the limit process in evaluating this integral. The limit of the integral of x e raised to negative x dx with limits from 1 to b as we approaches positive infinity. Okay? Then we use here class tabular method in evaluating this integral since it is by parts class. Okay? Tabular method, integration by parts class. The function that we will differentiate is x according to Liat class, the acronym Liat. Let's say familiar with Liat, no? So whichever comes first, that would be our u. X is an algebraic function and e to the negative x an exponential. So this is our u, the algebraic, and our dv is exponential. So meaning for our algebraic, this is the function that we will differentiate this. Derivative of x is 1, the derivative of 1 is 0. Then for e to the negative x, its integral is negative e to the negative x. Then again, we integrate, this is now positive e to the negative x. Follow? So with that, what's the integral of x e to the negative x dx? So apply the formula uv plus integral of u dv equals uv minus the integral of d du. Okay, for our u, it is x plus, okay, since we use na pala tabular method, so we will not be using this now. Okay, this is the usual formula for integration by parts, no? But we applied pala tabular method. So we get now the product here, positive, no? Alternative positive, negative first. However, still this is negative x into the negative x. Then this one plus, that would now be plus e to the negative x. Of course, we need to add c here. Okay? And then, okay, I'm sorry, this should be minus pala. Okay? The product kasi for this diagonal is negative e to the negative x. So we may factor out negative e to the negative x. So this is just x plus 1 plus c. Follow? Okay, so with that, okay. So we continue now with the solution for this one. This is negative limit of x into the negative x plus e to the negative x with limits from 1 to b as we approaches positive infinity plus. Okay, and then we replace now for x the limits. Upper limit first, negative limit of b into the negative b plus e to the negative b. Okay, then we take the lower limit ng class. So minus 1 e to the negative 1 plus e to the negative 1. Okay. As the approaches positive infinity. Okay, let's try working on this class. Okay. So for the limit of b e to the negative b as b approaches infinity, what we have to plus is infinity times 0, right? So the right is now plus as limit of b over e to the b as b approaches positive infinity. So the formula is infinity and infinity. So with that we use multiples to now. Limit of derivative of b is 1 and then derivative of e to the b as b approaches positive infinity, and this is not as 0. Okay. Next is what about this one, please? Okay, we can readily evaluate that, right? We have e to the negative infinity plus b is 0. Okay. What we think is our answer to this? This is 0. This is 0. So this is now 2 e to the negative 1 or 2 over e negative. Follow? And then we have the negative. So the answer now plus is positive 2 over e plus. It's a finite number. So the integral converges. So as the series will now plus converges. Okay? Any question, class? For the solutions of A and B here, and you may take a screenshot or a photo of the solution. Are you done, class? And do you have any question? If none, class, I can clear this slide. Okay? Then we'll try solving the procedure class. Okay? I'll clear the drawings in class. Okay, let's have letter C class. So for letter C class, this is limit comparison test, right? Under limit comparison test, you still recall we are to evaluate the limit of AK over BK as K approaches positive infinity, such that the value here test must be greater than 0 plus and said to be finite. Okay. So for our AK class, automatically the given term plus, which is 1 over square root of k plus 1. Okay. What about our BK? We just remove the constant term in the denominator. So that will give us our BK as 1 over the square root of 2. And then we now substitute. We have the limit of, for our AK, it's 1 over the square root of 2 plus 1. And then we now take the reciprocal of 1 over BK here, which is now square root of k over 1, or simply square root of 2, as k approaches positive infinity. So with that, this is the limit of the square root of 2 all over square root of 2 plus 1 as k approaches positive infinity. You may rewrite the ratio here plus as well. 1 all over 1 plus 1 over square root of 2. Follow plus as the approaches positive infinity. So obviously, if we now replace simple little limit, what we have to plus is 0 here plus. The one that involved square root of 2 plus. Since we are to replace 3 by infinity. So the answer plus is 1 greater than 0 if finite. Okay. However, class, we need to determine if the series now converges or diverges using, of course, the simpler term here, that of BK. What can you say about BK, please? What can you say about this series? Diba, class, this is a P series, right, class? It's a P series with the value of P plus us 1/2, in which we compare it with 1 plus. Okay, since 1/2 is less than 1, so the series here diverges. Okay, so since summation of 1 over square root of k with k equals 1 to infinity diverges, so as the series, that is summation of 1 all over square root of k plus 1 with k equals 1 to infinity diverges. Okay, any question, class? We take a screenshot now of the solution. Any questions so far? None? Okay, so I'll clear the drawings now, class. Then we'll go to the next slide, please. Okay, class, we still have problems here on CO2, but it's now 11:18. So let's have CO2 first, class. Then we'll go back to these problems if we still have time. Huh? Para somehow we may discuss all the COs for MATH148. Okay. So we have this later, please. Huh? Set this problem, please, for CO3 now. So, set problem number 1, please. This is for CO3. Okay. Find two unit vectors that are parallel to the YZ plane and are orthogonal to the vector u equals 3i minus j plus 3k. Okay. Plus when say YZ plane, this is represented, of course, by the equation x equals 0. So if that's the case, we will now define a vector normal to the plane, or let us say 1 plus as a vector with components 1, 0, 0. Follow? Okay. And then we have a vector u plus 3i minus j plus 3k, or we may have this in component form plus as 3, negative 1, 3. Okay? So we want two unit vectors that are parallel to the YZ plane and are orthogonal to the vector u equals 3i minus j plus k. So what should be done here now, class? Okay, so we have here, class, let's say we assign that vector as b, and then if we divide it by its magnitude, that will give us now plus the unit vector. We may represent this as double e plus. Since we want two unit vectors, so we have the positive, negative. Okay, so we need to define here plus our d first. Okay, so to define d, okay, we take now the cross product of these two. Okay, so first row would be ijk. Second row, the components of the vector n1, 1, 0, 0. And lastly, we have the components of vector u, 3, negative 1, 3. Okay, so we have a determinant 3 by 3. We just copy the first two columns na lang, plus evaluate this determinant. Okay, so what do we have here, class? So by array method or diagonal multiplication, that is now 0, 0. So we have negative k. This is 0, 0, and that is minus 3j. Okay, but we get the difference na negative k minus minus 3j lang pala. So with that, we have a plus in component form. There's no I, so 0. J is negative 3 and our k is negative 1. Okay? Then we take the magnitude. Okay, for the magnitude, please. or the magnitude. This is the square root of 10, right? So the two unit vectors will then be positive, negative. We have the vector component 0, negative 3, negative 1 over square root of 10. Or this is positive, negative, 1 to negative 3 over square root of 10 I minus 1 over the square root of 10j plus. Okay. Ah, wait, plus this should be j, then this is k plus. Okay, so any question, class? Okay, so let's have another this problem here, class. Number 2. Odd feeder always know, class. Okay, for problem number 2. Find k so that the plane quantity k plus 1x minus y plus quantity 2 minus kz equals 5 is perpendicular to the plane 2x plus 6y minus z plus equals 0, and find the parametric and symmetric equations of the line of intersection of these planes, class. Okay, so we have 4 plane M defined by this equation, class. Quantity k plus 1x equal minus y plus quantity 2 minus kz is equal to 5. Okay. So here, class, the normal would be k plus 1 and then negative 1 and then 2 minus k. Okay. For plane 2, it is defined by the equation 2x plus 6y minus z plus 3 equals 0. We will define N2 here, plus as well. 2, 6, negative 1. Okay. Then, as stated here, class, the two planes are perpendicular. So as the normals, class, they are also perpendicular. So this would mean then getting the dot product of these two, class. Okay, so that is now k plus 1 times 2. Then minus 1 times 6 or plus negative 1 times 6 plus 2 minus k times negative 1 equals 0. So this is 2k plus 2 minus 6 minus 2 plus k equals 0. So we have 3k minus 6 equals 0. The value of k plus is 2 here. Follow? So if that's the case, we will now have our n1 component. Substitute 2 plus 1 is 3, negative 1, and then 2 minus 2 there plus is 0. Okay? Then next class, the two planes intersect plus, as is stated here. The two planes intersect. So the intersection then plus is a line. Hello? So for that line L, we need to have a point and a vector parallel to the line here class, right? For that vector, it would just be the cross product of the two normals. So we have here I, j, k, and then our n1 as 3, negative 1, 0, and for our n2 plus as 2, 6, negative 1. Okay? And then class, we use array method or diagonal multiplication. So we copy the first two columns here class. So we have the vector here now plus as I plus 0j plus 18k minus that's negative 2k plus 0i minus 3j. So with that, we have our vector b as I plus 3j plus 20k. Hello? Component 1 plus we have 1, 3, 20. Okay, so what's next? So we're done with P. So next would be P plus. For our P, we consider the two planes class. Okay? Equations of the two planes. So for our M1, it's now 3x minus y equals 0. And for our plane 2, we have 2x plus 6y minus z plus 3 equals 0. Okay? So we need to define a point here class. The intersection of the planes is a line. Okay? Suppose plus the line L intersects the xy plane. So this would mean then that the value of z is 3. The value of z plus rather is 0. No? So in our second equation, that would just be 2x plus 6y plus 3 equals 0. Or you may have it as 2x plus 6y equals negative 3. And then the other equation here plus 3x minus 1 equals 0. By calculator class, the point of intersection here for our x, it is negative 3 over 20. And for our y, it is negative 9 over 20. And of course, for our z plus 0. So that would be the point now. So we will now define the parametric equations of the line plus x is equal to, this is actually x o y o z o plus, okay? The point of intersection. Okay, then we have that as x o y o z, para we cannot get confused with our x, y, z here. So that's negative 3 over 20 plus t. Then we have y equals negative 9 over 20 plus 3t. And then our z is equal to 20t. Okay, this is the parametric equations plus of the line. Parametric equations of the line plus this. Okay, what about the symmetric? Okay, for the symmetric equations plus, okay, that would be x plus 3 over 20 all over 1 equals y plus 9 over 20 over 3, okay, plus z equals rather, equals z over 20. So all you need to do here plus is to solve for t, then equate, okay, equate. So this is the symmetric equations of the line. Any question plus for our solution? Can we take a screenshot now? Okay. Are you done, class? No question? Okay, let's say. Okay, yes. So, class, let's say this is skip first class. Now let's have CO formula. Okay? Yung mga importante na lang class. Ito, let's have this problem. And if you still have time, babalikan natin. Okay? Okay, let's have the solution now, class. To this problem, use the method of Lagrange multipliers to find the points on the surface xy minus z squared equals 9 that are closest to the origin. Thus, the first multiplier is just another way of solving optimization problems. Okay? So, we have two functions here plus f and g. F, the function that we will optimize, and g would be the function, that's the condition. Okay? So that's the case, class. We have this equation, no, of the surface. So we have xy minus z squared is equal to 1. We want points on the surface. Okay, we represent the point plus as x, y, z. Order triple of numbers closest to the origin. Of course, for the origin, coordinates are 0, 0, 0. Okay, so we consider this Laplace as our function g. Okay, so for the function g plus, actually we may omit the constant plus, no? 9 xy minus z squared. This is the condition plus. So we'll take that as our function g. And the quantity that we will minimize kasi closest plus n. The distance, no? The distance between these two here plus. Okay? So recall the distance formula plus the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Okay? So that's the case we have now for our d as the square root of, let this be our point 1, this is our point 2. So that would be simply the square root of x squared plus y squared plus z squared. Ano? Then we may remove the radical. D squared is equal to x squared plus y squared plus z squared. So since this is the quantity that we will minimize, that would be the function of Laplace. Okay? Plus, yes, that would be the function of. Okay? We have x squared plus y squared plus z squared. Okay? So we now take the partial derivative surplus. So that would be the gradient now. Okay? So the gradient for the function g plus, okay, we take the partial derivative of this function plus with respect to x first. So what do we get? It's just y times I plus, okay, y times I. Then next is we take the partial derivative of this function with respect to y now. It's x times g. Then we take the partial derivative of the function with respect to z. We have negative 2z. Okay. Next class, we take the gradient of the function f here, represented by the symbol del. No? So, with respect to x, that would be 2x times I. With respect to y, 2y times g. With respect to z, 2z times k. Follow, and then with the Lagrange multiplier plus, what do we have? This one. This is the Lagrange multiplier plus. This is scalar here. Okay. So that would be equating na lang plus, no? We have I 2xi rather. 2xi plus 2yj plus 2zk is equal to lambda, and then we have yi plus xj minus 2zk. Then equating coefficients of I class. That would be left and right. 2x equals lambda y. So here, our lambda is 2x over y. Next, that of j plus equating coefficients. We have 2y is equal to lambda x. So our lambda is 2y over x. Follow? And then the last one here plus is k for our k plus. What do we have? 2z equals lambda negative 2z. Okay. So if that's the case, our lambda here plus is negative 1. Okay? Negative 1 plus. So what's next now? We equate them. Okay? We equate this 2 here plus 2x over y is equal to 2y over x. Then we have 2x squared equals 2y squared. Simplifying, x squared equals y squared plus. Okay, and then what's next? We solve for x plus. Or if you want to may solve for y, positive, negative y. Okay? So next now class, we substitute in this equation plus xy minus z squared is equal to 9. So let me get here plus. If y is equal, or we may have the plus as equals positive, negative x. So if y is equal to x, so what is this? X squared minus z squared equals 9. 5 plus. Tama ba? Yes. If y naman is negative x, what do we get plus? Negative x squared minus z squared is equal to 9. Kaya lang may problema, teka. Okay, plus. Ano yung given ko plus dapat ito ay z squared minus xy equals 9 pala to. Kasi nagne-negative dito. So kung mag-a-adjust tayo plus, mag-make some adjustment. Kung positive to negative dito, nako, sa total mess ng plus, no? Z squared negative dito. So kung ganun, this is negative y ay dapat. This one is negative xj. This is 2z. Yun lang naman mag-ano tayo dito. Make some adjustment. Negative y ay minus dapat to plus. And then this is 2zk. Okay. 2x equals dapat negative to. So there's the negative there plus dapat negative to. So this is now positive, dapat 1 to. So negative 2x negative. So still positive yan. So dapat to plus is negative. This one is positive. Positive to. Then that's negative pero positive to. Ayan. Okay, so may maremedyohan na class. So obviously, what is this? If we add the two equations, 2z squared is equal to 18. So z squared is 9. So we have z plus has positive negative 2. Okay. So we may now solve for x and y class. Okay. Again, refer to this equation. So we now consider the equation z squared minus xy is equal to 9. Okay. Okay, that should be the equation class. So we have our z, whether that's positive or negative, 3 squared still, that would result to 9 plus, right? And if we replace y by x here, so what do we get now plus? 9 minus x squared is 9, negative x squared is 0, so x is 0. So meaning, y is also 0. Okay, if we consider this as negative, x naman plus, okay, we replace y by negative x, diba? So that would now be positive negative 3 squared minus x times negative x equals 9, 9 plus x squared equals 9. So x squared plus is 0, still x is 0, as well as this is the value of y. So therefore, we have now the points 0, 0, 3, tsaka 0, 0, negative 3 plus. Okay? And plus yun yung sagot. The points on the surface closest to the origin. So we may not take a screenshot plus of the solution. Kaya pa ba? I think so. Still have 7 minutes na class. And
Sir, saan po yung final answer dyan?
yung 003, 00 negative 3. Kasi points ang
Okay.
points ang hinahanap anak eh. Points on the surface. Okay? So di ba nakuha natin dito x0, y0, and then we have their z positive 3. Tama? So ibig sabihin whether z is positive 3 or negative 3, x and y values both zeros. Kaya ito na yung points mo. Okay, next class we clear the drawings now. Let's set this problem here. Okay. This one class. Use the method of Lagrange multiplier here. Class for this problem, a rectangular box with a volume of 16 cubic feet is made from two kinds of materials. The top and bottom are made of material costing 10 cents per square feet. So this would we have a closed box here, class. The sides from material and the sides from material costing 5 cents per square feet. Find the dimensions of the box so that the cost of materials is minimized. So let's set the dimensions here as x, y, and z. Okay? So the volume test is given as 16 cubic feet. So we will treat this as the constraint class, no? The function G class. Okay? And then the quantity that we will minimize the cost class. And so for the cost, top and bottom, 10 cents per square feet. Okay, the bottom class is a rectangle, area is xy. Since we consider top and bottom, so times 2. Follow? Plus, the other side's now plus. We have 4 rectangles. Okay, so that would now be 2xy. I am referring, 2xz rather. I am referring to this. 2xz times 5 here. Okay, plus, then we have also 2yz here times 5 also. And plus, besides costing 5 cents. Okay, so we have now 20xy plus 10xc plus 10yz. And we will treat this as our f of xyz, the quantity that will be optimized, in this case minimized. Okay, plus, so our f of xyz is 20xy plus 10xz plus 10yz. We obtain the gradient here plus. So what do we have? Obtain the partial derivative with respect to x first. So 20y plus 10zi plus, take the partial derivative with respect to y. We have 20x plus 10zj, and plus, take the partial derivative with respect to z. That would now be 10x plus 10y. Okay, hello? For our g of xyz, that would just be xyz plus. We'll not include anymore the constant. Okay, there's no need naman na plus. We take the partial derivative of this function to obtain del g or the gradient g plus. So what do we have here? So with respect to x, so yzi. With respect to y, xzj. With respect to k, xyk. Then we use now the Lagrange multiplier here plus del f equals lambda del g. That is 20y. Okay, let's have now comparing now plus coefficients of I. That's 20y plus 10z is equal to lambda yz. So what is our lambda here plus? 20y plus 10z over yz. Then let's have j plus. For our j, 20x plus 10z, okay, is equal to xz, lambda xz. So what is our lambda here? 20x plus 10z all over xz. By the way, plus we may simplify this as 20 over z plus 10 over y. This one will be simplified also as 20 over z plus 10 over x. Then with respect to k plus, what do we have left side? 10x plus 10y is equal to xy here plus. Follow? Just equate coefficients of I, j, k both sides times lambda here. So what is lambda? 10x plus 10y all over xy. So 10 over y plus 10 over x. After which we equate any of the three plus 2. Ang pipiliin natin dalawa ha. Okay, let's have 20 over z plus 10 over y here equated to this one plus. That will involve the lambda, diba? 20 over z plus 10 over x. This cancels now, class. So 10 over y plus 10 over z, we may cancel out 10 also. So it would mean then that y is equal to x for this equation. Right? Okay, next class. We may equate this to this one. Okay, what do we get here? 20 over z plus 10 over x is equal to 10 over y plus 10 over x. So this cancels. What do we have now? 20 over z equals 10 over y. So this would mean then plus that 20y is equal to 10z. So z plus is 2y. Hello? Then we go back to this equation now. Okay, we go back to that equation. So we'll retain na lang plus y. So first is we replace x by y. We'll retain y and we'll replace z by 2y. So what is this? 2y cubed is 16. So y cubed is 8. Therefore, the value of y is 2. It's also the value of x, 2. And for the value of z is 4. So this is now the dimension class. It's 2 feet by 4 feet. Okay? And check this. Any question? Class? Ito galing. Okay? Let's find the Lagrange multiplier in solving this problem class. Okay? You may now take a screenshot or a photo of the solution